Good morning, dear students. How are you all? Fine. Okay, so this is a video of class 11, and in this video we are going to discuss about the physical properties of alkanes. And here you can see that first of all we are going to talk about the boiling point. As you know, as the molecular mass of the different alkanes will increase, different alkanes in the sense of that methane, ethane, propane, butane, if there would be increase in the molecular mass, its boiling point will definitely increase. So here I have taken one of the question, and in that question it is given that out of these pentane, 2-methyl butane and 2,2-dimethyl propane, which one has high boiling point and why? The reason is there. Reason you have to write. So the reason is given, and first of all you can see the answer is pentane, because if you will write the pentane, it will contain such a long chain. C 5 carbon would be there. Okay, na 5 carbon would be there. That means long range of surface area it will cover. That means long point of contact would be there. So surface area will increase, the point of contact will increase. That means it will have the highest boiling point, and such it is given as 309.1 Kelvin. Whereas 2-methyl butane, that means this carbon I will take from here and its isomers would be there. So I will place it from at the second position, at this position C. So what will you get? You will get 2-methyl butane, and you know that just it is coming in the spherical shape, and 2,2-dimethyl propane. So again this carbon it shifted onto this one, so again you will see the spherical shape would be there, and its boiling point would go on decreasing continuously. So here the reason is actually given. So you can see the reason: with increase in number of branch chain, the molecules attain the shape of a sphere. As the branching will increase, the molecules will attain the shape of a sphere. That means the smaller area of contact would be there. If a smaller area of contact would be there, that means weak intermolecular forces would be there, and for breaking that weak intermolecular force, such a low amount of temperature it is required. And if it requires low amount of temperature, that is the reason why it is having the less boiling point. So our answer is pentane, which has high boiling point because the surface area is maximum in that case. Okay, now we will see the more physical properties. Please wait. So here we will see the physical properties of alkanes in detail. The very first point I am going to write, and that one is non-polar molecules. Here I will write non-polar molecules. Okay, as you see, some of the compounds name I will write CH4, okay, CH4 or C2H6, C3H8, whatever alkanes you have to write. And when I will write the open structure of this one, C hydrogen, 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 okay, this one hydrogen, second, third hydrogen for this carbon, 1, 2, 3, and C, 3 hydrogen at the terminal position, okay, and 3 hydrogen also for this terminal carbon, 2 hydrogen for this one. Now as we are talking about the non-polar molecules, that means there should not be any difference in the electronegativity. Okay, now so you can see C here, carbon and hydrogen. The electronegativity difference between carbon and hydrogen is negligible. Okay, now the difference between carbon and carbon on the basis of electronegativity, okay, now there is no difference between the same atoms in case of electronegativity. So electronegativity is not there. And what is non-polar? Means non-polar is that type of compound which is not having the electronegativity different. If suppose I will tell HCl, Cl is the Cl is having more electronegativity as compared to this hydrogen, so it will pull all the electron of hydrogen. So this one is a polar compound, but in this case, as this chlorine is having more electronegativity, so it will pull the electron of hydrogen. But in case of this carbon and hydrogen, if the same electronegativity would be there, no one will pull the electron of other atoms, so we can say this one is a non-polar molecules. Okay na? So first physical properties you have understood, non-polar molecules. Second, the colorless, and second properties is colorless and orderless. Okay na? But if you will ask the question, sir, why this, if it is butane is there in the cylinder with some composition of ethane is also there, so why that after leakage it is started to smell? It is not due to that methane, or it is not due to that of alkanes, it is due to some of the additive product, and that one is ethyl mercaptan. Okay na? So that we can say the physical properties, it is colorless and odorless. Okay, next, third one, they possess weak van der Waals force of attraction. Van der Waals force of attraction. Okay na? As there is not a compact arrangement between the carbon and hydrogens, you can see, so there would be the less weak van der Waals force of attraction. And we will talk about at 298 Kelvin temperature, the existence of these all the alkanes in states, in the case of states. So if I will talk about the number of carbon in any of the structures, C1 to C4, if it is there, carbon 1 to carbon 4, that means it will exist into the gaseous state. Okay na? Then after C5 to C17 at 298 Kelvin, that means 25 degrees C temperature. C5 to C17, any of the structure, if it is containing C5 to C17 structure, it will exist into the liquid state. Okay na? And if I am talking about more than C18, or more, okay na? So this will exist into the solid state. So here, this is the physical properties of the alkanes. Okay, now the boiling point we will talk. Here boiling point is just increasing. If CH4 I have written, C2H6 I have written, C3H8 I am writing. Just don't, if I am going from number 1 carbon, n is equal to 1, to number, this n is equal to increasing, then the molecular mass is increasing. Hence, we can say the molecular mass will increase, that means molecular mass will increase, that means boiling point will also increase, because that requires more temperature to burn, to melt that one, to break the force of attraction between these higher molecular masses compounds. So we can say the boiling point will increase in the case of alkanes higher membranes. Okay, members, sorry. So you have seen that down the group, if I am talking about N1, N2, N3, N is number of carbon, N is number of carbon, N is equal to 2, N is equal to 1. So the boiling point with increasing in the molecular mass will increase, boiling point will increase. Now we will talk about the solubility. You can see solubility means what? Solubility means in a solvent, if some solute is actually dissolving in that one is the solubility. If I have talked about the water, okay, water is a polar compound. Water is a polar compound because H plus OH negative is there. So polar compound, in this one H plus Cl negative is soluble. Okay, why it is soluble? Because polar plus polar will be soluble. Okay, now, and non-polar is soluble in non-polar only. Okay, now, so soluble. Here we can write soluble again. Okay, now, so here what I am going to discuss about this in the solubility means like dissolves like dissolves like. Okay, now, like dissolves like means kerosene can dissolve in petrol. These both are non-polar compounds, so that one will dissolve into together. So that's why like dissolves like means polar will dissolve the polar molecules. If there is a difference between electronegative, then we can say that would be the soluble. But if you are saying non-polar compounds are there, then only non-polar will dissolve in that one. Okay, now, so we have discussed all the physical properties of the alkanes. Thank you.